So this is a brief presentation revisiting the concept of scoping. So in this example here, we have a slice of PCAP data. PCAP data is just network traffic of a black hole exploit. And what we can see from just looking at the IDS IPS alarms is that we can see that a PDF was downloaded. We can see that there was some form of payload from a black hole kit or an exploit kit. And then we can see another PDF and another executable. But the question really remains on scoping is where are the attacks coming from? Are they just coming from these two sites? And was this attack successful? So one thing that we can notice off the bat is that the host name from these particular pieces of attack are consistently the same, right? But however, not the systems. So we actually see three systems involved. And this is the first hint that what we're dealing with is what we call a fast flux. A fast flux is when the attacker takes all these compromised machines and then they point you to these compromised machines, which are just proxies. So we can't just blacklist the server. This is a good example of knowing how to blacklist a URL or a host name. In this case here, the host name. That's where the attack is coming from. But let's pivot on this attack and ask ourselves, what is the client seeing? And if we were to take a look at what the client's seeing, the first thing we're going to notice is that when we pivot, we see that there's also a site from Romania involved with the attack. And here, the host name is actually a number. It's kind of strange to see a number. What a number really is an unsigned 32-bit int. And those unsigned 32-bit ints, believe it or not, equal the IP address. So this is a way a hacker gets around looking like an IP address, but still routing like one. The use of unsigned 32-bit ints, even hex numbers, are known by the browser, and so the browser can go to these places. The strange part is most IDS, IPSs, and firewalls and gateways don't know how to handle these numbers, and so they let them just through the system. And so this is an excellent way for the attacker to get around detection. But now we can detect it by pivoting it and scoping around the site that we know is the issue. So the first thing we can realize is that there's other attacks coming in. The next thing as we go down the list is we can see where the executable hits, and then yes, we now see call outs yet to a brand new IP address, right? And this search, and this is very common. The use of search is such a common text that post into a search allows the attacker to send information back. And so what we're seeing is here's the exploit and here's the callback. And we can see another callback and another callback. These DNS requests are again going to systems and finding out, can I communicate back? Eventually, it winds up finding another machine by which it can communicate back to. And so what we're going to do at this point here, as far as scoping goes, is we want to take a list of all the host names that are involved and all the IP addresses that are involved. Now again, the IP addresses in these cases are usually compromised machines, but yet we can still block them as long as we have a very good dictionary or a very good collection of them. Now, from that perspective there, we can always cluster around and say what hosts are involved, and we can subtract the ones that we know. So there are things like the Google Safe Browsing, Microsoft, which we know are cool. The other issue is, and here's the CNN, is sometimes one, there's also the normal user traffic, and two, there's callouts. But in general, what we can do is we can start collecting all the places that we know are bad host names and bad IP addresses, and then be able to piece together the puzzle. So to wrap it up, because all we really do is talk about scoping in this case here, is what is scoping? So if we went back and we took a look at, again, the IDS IPS alarms, we'll notice there's a small number of alarms for this particular machine. But when we drill down and we took a look at all the flows of that machine, not only can we validate that the attack executed, we actually can begin to see the covert channels and begin responding to do the quarantine. So remember, at this point here, we're looking for data for three particular actions. The quarantining of the system, which means not only the containment of the system that's infected, but also making sure that it doesn't call back out. The second piece is the cleaning up of that system. And we can see here that we get a number of executables and PDFs. We can go to the file section and we can now have the MD5s that we can use to search and find these We can run these in a sandbox and find out what they're doing. Most importantly, we know what we're trying to clean up on this system. Lastly, the prevention. And if we go back to that system, we take a look and we pivot, we can work on preventing not only the covert channels, we now know the host name that's coming in, and we know some of the IP addresses for the fast flux. So we have a really good beginning to how to prevent this attack, not only from growing in my organization, but from expanding or even a reoccurrence. I hope that really explains what scoping is, and we'll revisit the concept of these attributes and how these attributes help us respond.